Alright, to begin this video, I want to remind you of a formula. We have if A and B are events, then the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Now, if A and B equals the empty set, then the probability of A and, well, let me make my ands capital so that I'll write lowercase ands for other things. Then the probability of A and B equals 0, since there's no items in the and part. In this case, A and B are said to be mutually exclusive. Now, there are times when A or B equals S, the entire sample space, if that happens, the probability of the entire sample space is 1. So since the probability of the entire sample space is 1, we have the probability of A or B equals 1. Now let me go ahead and then break up this formula. Off to the left, then we have the probability of A plus the probability of B minus the probability of A and B equals 1. But if they're mutually exclusive, that's what I'm assuming for this portion of it, I get the following. I get the probability of A plus the probability of B minus 0 equals 1. So we have the probability of A plus the probability of B equals 1. Well, this is very interesting now. So we have, let me write this down concisely. If A or B equals the entire sample space, and A and B equals the empty set, then the probability of A plus the probability of B equals 1. A coin is flipped 3 times. What is the probability of exactly 2 heads? Let me write out the sample space. S equals, so we're flipping a coin 3 times, so we can go and have 3 heads and no tails, or we could have 2 heads and a tail. I just got to make sure I count all the ways that I can have that, so I think I've got that. And then we could have 1 head and 2 tails, And then finally, we could have 3 tails. The probability of 2 heads equals, now let me go through here and take a look. The size of S is 8. Now the probability of 2 heads, I got to count how many places have exactly 2 heads. So there's one of them. This is 2 of them. And that's 3 of them. No other places. So I have 3 out of 8 is the probability of 2 heads. Now that we have that, what is the probability of getting anything besides 2 heads? So this is what we have to take a look at. When you flip a coin 3 times, we can do this. If we flip 3 times, we either get 2H or we don't. Or we get something else. How's that? So if I look at the event that contains 2H, so if I look at 2H or anything else, that collection of items is the entire sample space. You can always do this. You can always say if something has property X, then the collection of items that either have property X or don't have property X is everything. So the same thing here. So then when I take a look at the probability, and if I say 2H or anything else, I'm talking about things that are not 2H. That means that 2H and anything else that's the empty set. So now I can apply my formula. So I know that the probability of 2 heads plus the probability of anything else equals 1. So I can subtract the probability of 2H and get the probability of anything else equals 1 minus the probability of 2H. Well, we just did that. That's 1 minus 3 over 8, which is 5 over 8. So the probability of anything else is 5 over 8. Let me just write something here. If we have something like the probability of B equals 1 minus the probability of A equals the probability of not A. That means that's the probability that A doesn't happen. So this guy right here, when I did the probability of anything else, that was equal to the probability of anything other than 2 heads. Or another way to put it is the probability of anything else is equal to the probability of not 2H. So that's really what I want. The formula that I'm looking for then, if we have P of B equals 1 minus P of A, this means that P, the probability of B, is equal to the probability of not A. in my first grade class, there were 3 children named Brian, and I mean the first name. So 2 other kids besides me had the same first name. There were 70 students in my first grade class. If you selected a child randomly from my first grade class, what is the probability of selecting a child whose first name is not Brian? So think about it this way. If we grab a kid, either his name is Brian, or it could be a girl, either the child's name is Brian or not Brian. So the collection of all children whose names are either Brian or not Brian is all of the children. And so we may use this. The probability of not Brian equals 1 minus the probability of Brian. That equals 1 minus, there were 3 Brians out of 70. So this probability is 67 out of 70. A family plans to have 20 children. This means there are 2 to the 20th, which equals 1,048,576 possibilities. So we know that the size of the sample space is 1,048,576. Now, what is the probability of at least one girl? Now think about this. You have your 20 kids. Either we had 20 boys or we didn't. So at least one girl means that we did not have 20 boys. It means at least one of those 20 children was a girl. So when we take a look at this, we have all boys or at least one girl. So if I look at this collection, all boys or at least one girl, that equals the sample space because that does consist of everything. Obviously, if I take and look at the items that are contained within all boys and at least one girl, that's the empty set. So I can apply what I want. So I have the probability of all boys plus the probability of at least one girl that equals 1. What is the probability of all boys? Well, the probability of all boys is 1 out of 1,048,576. There's only one outcome that involves all 20 children being boys. The probability that I'm looking for is this one here. So I can subtract the 1 over 1,048,576 and get the probability of at least one girl equals 1 minus 1 over 1,048,576. So if you want it just as a simple fraction, then we'd have 1,048,575 over 1,048,576. I'm not going to bother with the calculator, but if you did it, it would be nearly 100%. If you take a 5-question true-false quiz and guessed at every answer, then what is the probability of getting at least one correct? So let's take a look at least one. We can take a look at, we get none correct, or at least one correct. That equals the entire sample space. And obviously, if I looked at none correct and at least one correct, that would be an empty set. So I can use my formula. So I can do the probability of none correct plus the probability of at least one correct equals 1. Now the probability that you get none of them correct means that the outcome that you're looking for had to look like this. I had 5 questions and I got them all wrong. So I had wrong, 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 wrong. 5 wrongs, and that is the only one outcome that has 5 W's. So this is 1 out of, since there's 5 questions, this is 2 to the 5th power. Let me write this down up here. N of S equals 2 to the 5th, which is 32. So if I want the probability of at least one correct, I'll subtract 1 over 32. And that, of course, equals 31 out of 32. Let me make a big note here. I don't know if I've specified it or not. For any event, we have the probability of E plus the probability of not E equals 1, so that we can use this formula if as long as any kind of an event that we use, we can also describe the event of it not happening. All right, I have a table here that lists the number of wins for red, blue, and yellow teams. So what I want to do is do number 12 and number 14. So let's take a look at number 12 and see what it says. Picking one of the red team's games randomly. So I'm looking in here. They have 11 games. What is the probability that they had at least one win? So what we could do is we could do the probability of 0 wins plus the probability of at least 1 win. That there equals 1, since 0 wins or at least 1 win is the entire sample space, and when you intersect the two, or you take the and of the two of them, they have nothing in common. Now the probability of 0 wins is 4 out of 11. And the probability of at least 1 win, I don't know yet. But I can subtract off 4/11ths to get the probability of at least 1 win equals 1 minus 4 over 11, which equals 7 over 11. Moving on to number 14, picking one of the team's games randomly. So I don't know exactly if it says one of the team's games. I'm guessing we may be talking about the totality here. So we need totals. So let me go ahead and get those totals. Here I have 13, 7, I got 10, 6, 13, and my total then is 23, 29, 39, 42. So the size of my sample space, well, I don't want to say, the sample space varies depending on the question. So it does belong here. The size of this sample space is equal to 42. Now, picking one of the team's games randomly was the probability it was not a blue team's game. So we have the probability of blue plus the probability of not blue. That equals 1. The probability of having blue, let's take a look. There's 19 blue out of 42, so let me put 19 out of 42 plus the probability of not blue equals 1. So I can subtract 19 over 42 from both sides. So the probability of not blue, that equals 1 minus 19 over 42, which equals 23 over 42. Next, we move on to a topic that many people think they understand, but you probably do not know the definition of: odds. In probability, I should say in probability theory, the odds for an event, let's call it E, is a ratio whose numerator lists all the outcomes favorable to E, and whose denominator are all the outcomes unfavorable to E. So you can take a look at this. If I want the odds of E, we'll say the odds in favor of E, that equals the number of outcomes favorable to E divided by the number of outcomes unfavorable to E. I think the easiest thing to do is probably, let's do an example to illustrate how you really do odds. And the odds that you hear on the radio, I'll discuss that in a minute. So when I talk about radio, I'm talking about the lottery. A lot of times the lottery is advertised on the radio and they tell you all about the thing. So in a lottery, a person chooses a 3-digit number. From a collection of numbers ranging from 000 to 999. So if you're talking about a 3-digit number, you can get anything from 3 zeros all the way up to 3 nines. So you can get 001, 010, 500, 384. Any of those are possibilities. In fact, what this tells me is that the size of the sample space is equal to 1,000. Basically, you pick a 3-digit number and you hope it matches some number between 0 and 999. If you buy one ticket, what are your odds of winning? So for that, let's take a look at how many numbers are favorable to you. So let E be the set of your number, whatever that number is, so that the size of E is equal to 1. Your number, you choose exactly one number, so the size of your, event is 1. So the only thing favorable to you is that one number. So when we look at your odds of winning, you have only one outcome that is favorable to you. That is if they choose that one 3-digit number that you picked. All the other numbers you lose. That means there are 999 other numbers that are unfavorable to you because they're not your number. So the odds of winning are actually 1 in 999, not 1 in 1,000, as would be advertised on the radio. By the way, odds of losing, you simply take the reciprocal of the fraction, 999 to 1. You do need the divided by 1 because you do need some items to be in the favorable position. The formula looks like this. Odds in favor of E equals the number of items in E, each of those would be favorable, divided by the number of items not in E, those would be unfavorable. So here you make perfect sense. Now, let me reiterate something like this. The size of the sample space is finite. Otherwise, if I tried to divide by n of s, it would zero the whole fraction out. So here we have the odds in favor of e. We can convert to the odds against e equals, just take the reciprocal of the fraction. All right, for my next example here, we have a couple is to have twins. Once you hear that, you should do this. The sample space of twins, you could have 2 boys. You could have a boy and a girl, or a girl and a boy. And then you could have had a girl and a girl. So the outcomes are 4. The total number of them are 4. Let me put n of s is equal to 4. Calculate the odds for and against for 2 boys. So let's take a look here. There's 2 boys, and no other outcomes are listed for 2 boys. So the odds for 2 boys equals the size of 2 boys divided by n of s minus the size of 2 boys. Well, the size of 2 boys, there was only one of those. Then s, the size of s was 4. The size of 2b is 1, so we have 1 out of 3. So keep this in mind. It's 1 for and 3 against. Together they add up to 4. Now, probability and odds. So if you take, let's take a look at our odds for an event. NE all over NS minus N of E. What I'm going to do is multiply the numerator and denominator by 1 over N slash E. What happens when I do that is I get a 1 in the numerator, but in the denominator, I'll get n of s divided by n of e minus 1, which equals 1 over, and then n of s over n of e, if you remember, that's 1 over the probability of e. So now, to fix this up, I'm going to multiply the numerator and denominator by the probability of e. And then when you multiply that through, you'll get the probability of e divided by 1 minus the probability of e. So this is the odds in favor of e. And then the odds against e, you just take the reciprocal. Okay, for my last example then, the odds for getting hit by lightning look like the following. Odds, I don't know, let me say odds in favor of getting hit by lightning. That equals the probability of getting hit. I'll just say probability of hit divided by 1 minus the probability of hit. So for this, the probability that you're going to get hit by lightning is 1 out of 12,000. And in the denominator, we're going to have 1 minus 1 over 12,000. Now, you could probably just use your calculator to do this, but I feel compelled to simplify it. So I'm going to multiply the numerator by 12,000 and the denominator by 12,000. And the numerator becomes 1. And down in the denominator, we get 12,000 minus 1. And so that's 1 over 11,999. The way you want to look at it is this way. If you're out on 12,000 consecutive stormy days where there's lightning, this is saying that 11,999 of those days you would not get hit. But on one of those days you would get hit. So of the 12,000 days, you have one bad day and the rest of the days are good. Now the odds against a lightning strike equals just the reciprocal, 11,999 to 1. And remember, don't forget to put that divided by 1. We need to know how many items are for and against the particular event.